Hello, let's talk about complex numbers. So let's start off when we're talking about complex numbers. Let's talk about the imaginary part and let's talk about its definition. By definition, that if I have I raised to the first power, which we don't write it on there because it's in simplest form, but if I have it raised to the first power, well, we know it's I, right? Because anything raised to I is just going to be what it is. I squared is negative 1 is equal to negative 1. I cubed is equal to negative I to the fourth is equal to 1. And then it just repeats itself. So every fourth one, every product divisible by 4 is going to give me back 1. Those are clues that's great to know. So my first example I want to do is I got the negative square root of 121. So what I'm going to do is break it down. I got this negative on the outside, so it's the same as negative 1 times the square root of 121. I know that most of you got a calculator and you're just going to type in. But in order to square root it without the calculator, we'd have to get the breakdown of 121 and we'd have to find a product of something times itself twice, right? Because that will give me a power of 2, and that power of 2 will reduce with the square root. So anytime I have, so if it's a power of cube and I had a cube root, those would reduce, right? So it's just things to think about. Go back to the exponential rules if you're struggling with this. All right, so I know that this here is negative 1 times the square root of 11 times 11, so it's 11 squared. So the square root and the square reduces, and now I got negative 1 times 11, which is negative 11. So that's my answer. And that's a real number, right? But let's talk about the square root of negative 18. So if I have the square root of negative 18, let's break that down. That's the same as saying square root of negative 1 times the square root of 18. Well, that root is an even root. So therefore, if it's an even root, this is not a real number. This is called my imaginary because there's no way I'm going to multiply something an even amount of times and come out with a negative answer because negative times negative is positive, right? That's even. However, if that was an odd root, say it was a cube root, if I multiply by negative, then it becomes negative, so that's real. So anytime your root is even, whatever's inside that root, if it's a negative number, then we know that negative value, or it could be a variable term in there, so it don't have to be a number. But anytime a negative is inside an even root, we know it's an imaginary. So I'm going to automatically call it what it is. I'm going to call it an imaginary number, and I'm going to call it I. Okay? So a little helpful hint is if I was to take this here and square root both sides to undo that square, it gives me a square root of negative 1. There you go. All right, so back to this one. Now let's look at 18. What's the product of 18? Well, I know what? 2 times 9? We all know that. So if I break that down one more time, and I like putting my eyes on the outside of the roots because if you put it on the back side of it and you accidentally scoot it back underneath it, then your answer is incorrect. So I just like putting that right up front. So now I got square root of 2 times the square root of 9. Well, we know 9 is 3 times 3, which is 3 squared. That reduces. And so now my final answer is going to be I, 3 square root of 2. Or we could write 3I square root of 2. Again, I want my everything that comes out of the root in front of the root if I have a root left over, just because neater and you don't make the mistake of putting it back under the root. All right, so that is just factored. So let's talk about what if I have an add or a subtract. And we have this real and imaginary part. And anytime we write A plus or minus BI, A is going to be my real part plus or minus my imaginary part. B is my coefficient on I, anything other than just 1, right? So this is the correct notation. So whenever we write our final answers, we always like to list the real part first. It there is something other than zero. If you get zero, just leave it alone. Well, I'm going to work this example of negative 2 minus 4i minus 1 plus 6i. What I notice is in front of this parentheses here, the positive 1, so a sign change on. I notice in this parentheses, I got a real minus an imaginary. Those two can't be put together. So if I wanted to, just for my own benefit, I could rewrite it and pull it out of the parentheses if I wanted to, only because the two binomials are separated by a minus sign. If the plus or minus sign is in between them two, I can do this step. If they're not, which we're going to work when it's not here with it. So since I got a negative sign, I could drop it. However, before I drop the parentheses on the second one, this negative does change everything inside that parentheses. So that negative times positive, which is negative, negative times positive, which is negative. So my next step is I'm going to combine new like terms. I see that this negative 2 and this negative 1 does not have, it is real, it doesn't have the imaginary on it. So I'm going to put them two together first. So I got negative 2 minus 1. So it's basically you're in the hole $2, you spend another $1, now you're in the hole 3. Now let's look at our imaginary part. It is negative 4i minus 6i. So you're in the hole $4, you spend 6 more, so it's a negative 10. That's my answer. So let's solve a multiplication one. All right, so say we have, I got so many pictures. I pulled up a bunch so that way I can. All right, we have a binomial times a binomial, so we're going to use the full method, right? So what I'm going to do is I'm going to do my first times my first. Multiplication is a little bit different. I'm going to do my outers. Oh, I'm going to put a plus sign here. My outers times will give me negative 1 times positive 3i. Let's do my inners, which I get like positive 2i times a negative 2i. Or no, there's no I on that. That's my last. So I got a positive 2i times 3i. And let's clean up. So negative times negative is positive. And 2 times 1, 2. Negative times positive is negative. And 1 times 3i. Negative times negative is negative. 2i times 2. And then I got 2i. 2i times 3i is 6i squared. Now, I noticed these two in the middle can be put together, but I also notice this I squared. I know I squared is negative 1. So what I'm going to do is rewrite that as 2 plus that 6 times that negative I squared. And the reason I did negative, plus out front, or sorry, I jumped the gun. I meant the reason that 6 is going to be negative is because of 3 plus in front of the 6. So I got negative 3i minus 4i gives me a negative 7i. This here becomes the negative 6. So now I have 2 minus 6 minus 7i, which my answer now is negative 4 minus 7i. And it is written in a real plus or minus imaginary. So you always want to find that. I want to do division. Let's talk about division. So if I have 2 minus 3i divided by 3 plus 4i, I have a fraction going on. And there's rules of things that you can't have in a fraction. We have negative values, we have decimals, fractions, roots, imaginaries, all of those can be undone by using a specific rule or following a specific rule of fractions. If you have zero, though, it's just undefined. So the rule here is we're going to use the conjugate. And what do I mean by conjugate? I'm going to write this first term in this operation. I'm going to change. It's a plus, so let's change it to minus. And then let's write our second. Whatever we did to the bottom, though, to undo the I, we must do to the top. And then I'm going to go ahead and use full method. I got my first times my first, so 2 times 3 is 6. My outer, so positive 2 times negative 4 is a negative I. Negative 3I times that positive 3 is my inner, so that gives me a negative 9I. And then my last, I got negative 3I times a negative 4I. So negative times negative is positive. 3 times 4 is 12. And then I times I is I squared. Now let's do the bottom. The bottom is 3 times 3, because it's my first. So that's 9. And then of course my outers, 3 times negative 4 is and I is a negative 12I. Do the inners, positive 4I times 3 is a positive 12I. And then last, positive 4I times a negative 4I is a negative 16I. What do I notice? I notice in the denominator, the middle here goes away. 12, negative 12I plus 12I is just 0. Also notice I got an I squared here and here, so I can rewrite those times the negative 1, right? For the I squared. Okay, so now I'm going to say 6 plus that negative 12. Let's put these two together. I got a negative 8I minus 9I, so it gives me a negative 17I, all divided by 9 minus 16 times negative 1. So now I got 6 minus 12 gives me a negative 6, 7 minus 17I over 9 minus 16. So let's contribute the I times, or negative times negative is positive. 1 times 6. So now I got 9 plus 16 gives me 25. This doesn't reduce. So, that's my answer. But let's write it as real minus the imaginary. One more. Let's do I to the 15th power. I'm going to simplify that down. I know that if I write everything to, or excuse me, not everything, if I write I to the fourth power, I know that I'm going to get 1 there, right? Because we know I to the fourth is 1. Let's talk about it. 4 goes into 1500 times. Well, we know it goes into it 3 times, right? 4 times 3 is 12. So I'm going to raise it to the cube. However, 15 minus 12 means we need to tack on 3 more, so that's I cubed. So 4, or I to the fourth power is 1, cube it is 1. And then I'm going to add on 3 more. I to the third power is negative I, so my